In this example, we're going to represent integers using the chip model. Determine the value indicated by the sets of integer chips below. So we're given a chip representation, these are chip representations, and we're asked to write the corresponding signed number. Let's start by going to the NLVM site and see what these chips represent. So here, I'm going to drag positive chips, so the plus means a positive chip, and notice that it says the sum is 1, or the number that we're representing. And the more positive chips I add, the larger the sum. So this would be positive 1, 2, 3, 4. Similarly, if I drag negative chips, one negative chip is negative 1, and this is a total of 3 negative chips, so it equals negative 3. Now here's something interesting that can happen. I'm going to click and drag here, and notice this is dragging both a positive and negative chip. And I want you to look at the sum as I drag these into this region. Notice it didn't change. This is still equivalent to negative 3. So we have 4 negative chips and a positive chip, but these two chips combined equal 0. They're not changing the cumulative value of these chips. So I could add as many of these pairs as I want, and this quantity still equals negative 3. So now let's use these ideas to fill in our chart. So here we have 1, 2, 3 positive chips. So our signed number will be 3, or if you'd like, positive 3. In this example, we have 1, 2, 3, 4, and they're all negative chips. So this represents the signed number negative 4. Now we have some examples that have both positive and negative chips. So we're going to need to use the idea that a negative and a positive, one negative and positive combined equals 0. So let's use our pen to circle some of these negative and positive pairs. So this is equal to 0, and I'm going to circle as many pairs as I can. Let's use different colors for the different pairs. That equals 0. Looks like we have one more pair of a positive and a negative. So all of these aren't changing the quantity when combined together, and we're left with 2 positive chips. So this represents positive 2. And in the next question, it looks like we have one positive chip that can be paired with a negative. And after we've done this, we see we have 1, 2, 3, 4 negative chips remaining. So this number represents negative 4. In this last question, we're asked to use integer chips to represent negative 5 in 3 different ways in the space below. Well, the easiest way to represent negative 5, let's use a text box here, is to use 5 negative chips. Okay, so there's my 5 negative chips, and these equals negative 5. I'm going to put it in a little box so we know it's one of our representations. So I'm going to write first way, so this is the first way we're representing negative 5. Okay. Well, now for a second way, I'm going to start with negative 5 chips. Let's put them like this. But in order to use a different way, I would need to include some pairs of positive and negative chips. So I'm going to include another positive and another negative. These cancel each other out, so this way is still equal to negative 5. So I'll put this as our second way of representing negative 5. And there are my 5 negative chips. And you can imagine we can add as many of the positive and negative pairs as we'd like. As long as we add the pairs, they'll cancel each other out. I chose to use 3. You can use any amount you want. And this will be our third way. So we have represented -5 in 3 different ways using integer chips.